So just so you know, I will be recording when we go over homework questions, both in this class and in my 7th period class. Sometimes those will overlap and sometimes they won't. So, but this will be up here, up on the YouTube channel if you need some help. If there's something we didn't go over today, for example, or if you're working on it late, you know, as some of you that had the big games last night, just know there'll be some resources online. All right, so 15. We've got cosine x minus cosine cubed x. And I've got my page of super fun trigonometric identities somewhere. I got them handy. Okay. I don't see anything with cosine cubed on this page. I see some stuff with cosine squared, but not cosine cubed. So I didn't give you this hint, but you just wrote it down on the stuff I had you start getting into your notes for today. And that is, look to factor. If you see something that you can factor, try and factor and see what that gets you. And this one, I see a common factor in both of these terms. What do both of these terms have in common? They both have a cosine in them. So I could factor out a cosine x. So this is like a GCF. I could factor out that cosine x, and that would leave me with what? This would be 1 minus, and then I'm going to lose one of these cosines, but I'll still have cosine squared. That's the key step right there. All right, now what is 1 minus cosine squared? What does that make you think of? Does it make you think of Pythagoreans? So we're going to talk about this in a second here. Actually, let's just go ahead and do this right now. This is going to go in your notes for today. Okay, right underneath that stuff that we just talked about. Starting today, I asked you not to do this for our first assignment, but starting today, when you see something like sine squared x plus cosine squared x equals 1, this is straight off of your identity sheet. I give you permission to do any basic algebra stuff with this identity. So, and there are a couple alternate forms of this identity. I could write this simply as sine squared x equals what? It would be 1 minus cosine squared x. You agree? So if you were ever to run into a sine squared x in your work or a 1 minus cosine squared x, you are welcome to use this as a replacement. Okay. What's the other version of this that I could do? If I got cosine squared by itself, what would it look like? It would be cosine squared x equals 1 minus sine squared x. Now, I'm not going to provide you with those alternate versions on the trig identity sheet. You're going to get the same version as we have here. But I'm hopeful at this point in your mathematical career that when you see something like tangent squared plus 1 equals secant squared, that you're comfortable moving that 1 over to the other side and making it secant squared minus 1 equals tangent squared. Are you cool with that? And from now on, I'm okay with that too. Okay, so going back to number 15, 1 minus cosine squared seems like maybe it's a version of that sine squared plus cosine squared equals 1, doesn't it? What would that be? 1 minus cosine squared. Oh, that would just be, if I move the cosine squared over here, that would just be equal to sine squared, wouldn't it? All right, so 1 minus cosine squared is sine squared. And I don't know that we can do anything else with that. I think we're just going to have to leave it there. That one's not so fulfilling. For those that are doing that great thing that I expect you to do and checking your answers in the back of the book, is that what the book told you the simplified version was? Yeah, that's all I see there. Okay, what else can we go over from our 23? 23. Ooh, this looks fun. So I said this last class, and I'm going to keep repeating it. The sooner you can internalize these things, the better. I'm telling you up front that you will have this sheet on your on your test, but I'll tell you that if you have to spend your entire test hunting down identities, if you don't have them, at least if you can't at least recognize what type of an identity you're looking at, you're not going to finish the test. Okay, so I'm hopeful at this point that when you see pi over 2 minus something, that you're thinking cofunctions. Have you gotten that far? Pi over 2 minus x, you're like, oh, that's one of those cofunction ones. And then if you have to, you go to your sheet, but that would be my first move here. Actually, even before that, I'm actually kind of thinking about canceling one of these cosecants. Could do that. Let's do the cofunction first, though. What is the cofunction of tangent? Cotangent. So that's just going to become cotangent x. Cosecant stays. And then, yeah, I'm thinking about canceling one of those cosecants. This with one of these down here. So then I'd end up with cotangent x over cosecant x. And there's just a single one down there. And I'm wondering if I split this up, wondering what's going to happen. I'm going to rewrite this as, instead of times divided by cosecant, I'm going to multiply it by 1 over cosecant. And I'm also going to, that's not really an identity, I'm just changing the way the fraction looks. Are you guys okay with me taking this cosecant x and turning it into a 1 over in multiplication instead? We're good with that. And then I'm going to go ahead and take that cotangent and turn it into sines and cosine. That's, what is that? That's cosine over sine, right? And anything else we can do? Oh, 1 over cosecant is sine. And that'll cancel with that sign on the bottom. So the final simplified version would just be cosine. All right, we could do 1 or 2 more. 24. One plus tangent x over 1 plus cotangent x. Yeesh. That looks fun. How do I want to tackle this? Anybody get anywhere with this? There's a couple ways I'm thinking about. I'm just curious. We could kind of look at some Pythagorean stuff, but we're missing squares on them, right? Tangent, it does make me think of Pythagorean with the 1 and so if you're looking at this and thinking Pythagorean, I think that's good. I'm going to teach you some tricks today. In fact, we might do it right now. I'm just curious if anybody came up with something just using the techniques I showed you last class. We could turn these all into sines and cosines. That's one way we could deal with it. That is a wonderful question. I'm so glad you asked that. Can I cancel these ones here? Yeah, so we can cancel factors. If I have a factor of the numerator and a factor of the bottom, or the denominator, I'm allowed to cancel those. One is a factor of the top and one is a factor of the bottom. But if I factor out a 1, I would still have the 1 plus tangent x. So in general, you can't cancel if you've got addition or subtraction. What you need to do is factor something out of that addition or subtraction. And if that factor will cancel with a factor in the numerator, then you can cancel. Do you understand? Do you guys understand what I'm saying when I say factors? Like these two things are factors. They're being multiplied together. If I had another cosecant on the bottom, which I did, I could cancel these. If you throw a plus in between there, there's no canceling anymore. Not unless you could actually factor a cosecant out. It's a super common misconception at this stage in the game. So I'm really glad you asked that question. Thank you. Yes. We could make this into 1 over cotangent. We could try that. You want to try it and see if it works? Just give it a shot. Do you want to turn them both? So your idea is to turn them both into cotangents or turn them both into tangents? So would you want to turn the top one into a 1 over cotangent, or you want to turn the bottom one to 1 over tangent? Either way, I think let's give it a shot. 1 over tangent. Okay, let's try this. I'm curious to see how this is going to turn out. All right, so we got some fractions inside of fractions. What I'm thinking about doing next here is turning this denominator and getting it as a common denominator. Turning this into a common denominator. And I could do that pretty easily because 1 is really easy to turn into a fraction, right? With any denominator you want. We've been doing fancy versions of 1 all along. What would be a fancy version of 1 that would be really convenient and would be easy to add with 1 over tangent x? Tangent x over tangent x. I just turn this 1 into a tangent x over tangent x. That would probably be my next move. Ooh, I like where this is going, actually. Once I do that, then I can combine those together into a single fraction. Now remember, really exaggerate your big fractions and your smaller inside fractions. This is tangent x plus 1 all over tangent x. And I like this tangent x plus 1 because that matches up here. I have a feeling that's going to end up canceling. So I think we're going to end up with tangent. I'm going to go ahead and rewrite this as instead of dividing 1 plus tangent x by this fraction, I'm going to multiply by the reciprocal of that fraction, tangent x over, and I'm just going to go ahead and flip that around so it says 1 plus tangent x. And oh my gosh, look at that. You nailed it. What a great idea. I had never considered doing this problem that way. These are going to cancel and we're just going to end up with tangent x. That's awesome. Question. So I did was I just you squared the top and the bottom. You're full of great questions today. I love that. You did. Okay, that's great. We got to be careful about this because if I have a fraction like 3 over 4, there are certain things I can do to this fraction and make sure that it's still equal to the same thing, 0.75. Squaring the top and bottom, is that going to give me the same thing? If I square the top and bottom, I'm going to get 9 over 16. And is that the same as 3/4? It is not. So is it a legal move to square the top and bottom of a fraction with what we're doing here, not with simplifying? So I like that you thought of that. I want you to keep it in mind because there are some tricks we can do to get things squared, but we can't just square the top and bottom of a fraction. I could multiply it by 3 over 3. That would be legal, right? And you would end up with a 3 squared in the top. That's one thing that you can do to end up with something squared. But we can't just square top and bottom. I'll show you the other way you could do this right now. Let me get another sheet. So, and we're going to be learning this today. So 1 plus tangent x over 1 plus cotangent x. Let me look at my sheet again. Cotangent x. So if I could turn it into 1 plus cotangent x squared, is this going to work for this one? I don't think it is. Never mind. What I was thinking is not going to work for this one. We'll get back around to it. What I was thinking about doing was, this will end up being a useful trick. I was thinking about multiplying by 1 minus cotangent x as a fancy version of 1. Because in doing this, that's going to end up being 1 minus cotangent squared x. That's like our difference of squares. And that's a technique that we'll use to get squares also. So I love that you're thinking about getting things squared so you can use those Pythagoreans, because that's going to serve you well when we move forward. It's not going to work out on this though, because this is going to end up giving me 1 minus cotangent squared x. And that's not what I want. I wanted it to be a plus. Yeah. All right, we got time for one more. This is really cool, Franklin. Thanks for that suggestion. 13. All right, 13. And then if we've got more questions, we should hopefully have some time. One plus tangent squared x over cosecant squared x. Ooh, that really makes me think of Pythagorean, that 1 plus tangent squared. Is that one of our Pythagoreans? It is, totally. Ah, it's secant squared, isn't it? 1 plus tangent squared is secant squared. So that would be my first move. Secant squared x over cosecant squared x. Okay. So my next move might be, and think about doing this if you ever get stuck in with a fraction like this. Secant squared x times 1 over cosecant squared x. Okay, if you ever get stuck and you've got a fraction situation, instead of dividing by cosecant squared, we're going to multiply by the reciprocal of cosecant squared. Sometimes doing this is going to help you see a move that you might miss otherwise. Yeah, because what is 1 over cosecant squared? That's sine squared, isn't it? So I've got secant squared x times sine squared x. I'm actually thinking about turning secant squared x into 1 over cosine squared x. We're just applying the reciprocal, two different reciprocal identities here. Now, if I stick them back into a single fraction, we got sine squared x over cosine squared x, which is tangent squared x. One more problem. Yeah, let's do 16. Oh, you're gonna love this one though. I am just changing everything into x's. So I see squareds, I think Pythagorean, and I see one. Sine squared plus cosine squared is just 1. This is just a 1 right here. Tangent squared is going to stay, but sine squared plus cosine squared is 1. All right. So this would be 1 plus tangent squared, and I think that's an identity too, isn't it? So, and it's okay. Like you didn't see that, but as time goes on, you're going to get better and better at seeing those things, right? So again, this isn't the type of thing that there is no step by step. I can't stand up here and teach you, you do this first, you do this next, you do this next. You've got to work your way through. You got to struggle a little bit. You got to try some different things. And over time, you are going to get better at seeing stuff. And I've already said it once, and I'll say it a second time, and it'll probably be 3 or more times this period. The sooner you can start memorizing and internalizing these things, the better. I'll tell you that we are right now for the next section we're going to do, we're not getting anywhere past these first 5 categories. Okay, so if you can start memorizing these things now, that's just going to help you see things faster and move through these things quicker. But there's no, it can't be a race, right? You've got to expect that you're going to end up going down some paths that you're going to have to backtrack and try something different. It's just going to happen. Okay. All right. Question before we move on.
So isn't there like a memorization test on Tuesday for the first 5?
Our memorization quiz is going to be. Do we want to do that on Tuesday? Let's see. I'll see you on Friday. Yeah, we should probably do it Tuesday. The sooner I can get you guys to know these things, the better you're gonna be off you're gonna be. I could put it off, it would give you more time, but let's just do it Tuesday. Yeah. You guys don't look happy. I am gonna teach you something different on Friday. A little more step by step. No, you'll like what we're doing Friday. Doing a lot of signs on Friday. You'll like a lot of signs. Step by step, cookie cutter math. Yeah, plan for a Tuesday. And then if I push it to Thursday, you'll be pleasantly surprised. Just through odd even.